All right. Next topic is rational expressions, or as I like to call them, computational drudgery. Only reason we're covering them is they're on the final. They're not going to figure too heavily into the rest of the class, but it's good to know how to be able to manipulate them. Put simply, a rational expression is a quotient of two polynomials. So you got a polynomial up top, let's say x squared minus 16, polynomial down bottom, say x squared minus 5x plus 4. That's a rational expression right there. It's just a fraction where the numerator and denominator are both polynomials. If you don't know what a polynomial is, you're watching these out of order because I just explained it in 1.4. Alrighty. So we got a simple agenda today. We got to simplify, add, subtract, multiply, and divide these things. Now, this looks like a messy fraction here, but we can actually simplify this quite a bit if we factor the numerator and denominator. That's what I mean by simplifying. Factor the top and the bottom. And that's pretty much the first step in any of these other problems too. Add, subtract, multiply, or divide. You want to simplify before you do that, just to save yourself some work. It's easier to work with simple expressions than complicated ones. That's why we simplify them in the first place. So x squared minus 16, if you've been paying along, you should recognize that expression. That's a difference of squares right there. That's x plus 4 times x minus 4. X squared minus 5x plus 4, I believe if they add up to negative 5, they must be negative 1, negative 4. Now we got an x minus 4 in the numerator and denominator. They are factors, so we can cancel them right out. Something's multiplied by the whole top and these multiplied by the whole bottom. You can cancel that right out. So we're going to cut those factors out. This rational expression is equal to x plus 4 over x minus 1, and that's what I mean by simplifying a rational expression. Not so bad. Of course, it gets a lot worse if you have more work to do. If I asked you to simplify, say 2x squared plus 7x minus 4, I am regretting this already, divided by 4x squared plus 2x minus 2. We're going to have to factor these, see if we've got any common terms, see if we can get rid of them. Okay. I'm going to use my good old slide and divide method. 2x squared plus 7x minus 4. Slide that and make a new polynomial, x squared plus 7x minus 8. Now, that'll factor as x minus 1. Yeah, x minus 1, x plus 8, right? So now we divide. We're going to make this 2x minus 1 and x plus 4. So that's the numerator. See, we divided by 2 here, but it didn't go in, so we put that as a coefficient. Incidentally, what's really happening here is that I'm multiplying the whole thing by the 2 I divided out again, because if you take x minus 1/2 and multiply that by 2, distribute that in, and what you get is 2x minus, well, what's 2 times 1/2? It's 1. So this is equal to that. So what's happening is that 2 you factored out is coming back in. That's all that's happening there. Other polynomial, 4x squared plus 2x minus 2. Slide that 4 right down and make a new polynomial that's easier, x squared plus 2x minus 8. And that factors as x plus 4 times x minus 2. Got to divide that 4 back out. This is going to be an x plus 1. X minus 2, well, this will be x minus 1/2, so we'll slide that 2 on up, 2x minus 1. So this whole thing is 2x minus 1 over, or times x plus 4, all over x plus 1 times 2x minus 1. Just like before, these folks can cancel out. We just get x plus 4 over x plus 1. This ain't going to happen every time, but happened both of these times because I design the problems to have it happen. I wanted to show an example where something actually cancels. Be a lot of kind of boring if we did all that factoring and nothing actually canceled, but it'll happen sometimes, so don't be shocked. So that's how you simplify a rational expression. Now, adding and subtracting can be a real pain, so let's do multiplying and dividing first. It's actually easier, believe it or not. Let's say I was trying to run x squared minus x minus 6 over 2x squared plus x minus 6. And we're going to multiply that by 2x squared plus 7x minus 15 over x squared minus 9. Now this is a real pain in the butt because we got 4 different polynomials to factor. Now I could multiply numerator by numerator and denominator by denominator. And that's what we're going to do in the end. But if I do that right here, I'm going to have a 4th degree in the numerator and a 4th degree in the denominator, and good luck ever trying to factor those. So instead, let's factor first, see if there's anything we can cancel out, and then worry about multiplying. X squared minus x minus 6, that's x minus 3, x plus 2, and this is x plus 3 times x minus 3. Already some good news. Cut those x minus 3s out right now. 2x squared plus x minus 6. Well, you've seen the method. It's going to be 2x plus something times x plus something, right? Those 2 things on the end, they got to be a 2 and a 3 to multiply to a 6, right? They got to be a 2 and a 3. So let's say it's, oh, I got it. Yeah, x plus 2, 2x minus 3. That ought to do it, right? Oh, no, other way around, right? Other way around. This, no, that'll do it. Yeah, because then the middle term will be 4x minus 3x. You see what I'm thinking there? I'm thinking of what's going to happen when I FOIL this. I know this number and this number got to make this number. Whoops. Looks like my hard-boiled eggs are done. Well, I'll go grab those in just a second then. But I was trying to see what this negative 3x and this plus 4x, those make an x together. I could probably do the same thing up here. It's going to be a 2x plus something and an x plus something. Knowing me, it's a 2x minus 3. And that would make this an x plus 5. And would you look at that? Yeah, I knew it was going to be a 2x plus 3, so it'd cancel with this guy. The x plus 2's cancel. And the other one's got to be an x plus 5 because negative 3 times 5 makes negative 15. And over here, the inside and outside are negative 3x and plus 10x. That makes a 7x. So after the dust clears, we're left with x plus 5 over x plus 3. All right, let me go get those eggs. I'll be right back. We'll do a second part of this video.